Okay, today we are going to do 9.7 and 9.8. It's on analyzing data displays, and then 9.8 is on misleading statistics and misleading graphs. Okay? So, here I have a histogram, and it says, how many people ages 70 or older had a net worth of at least 4.5 billion? So what I'm looking is for 70 and older, so that's this purple bar, this pink bar, and this blue bar, and they're asking me how many. So at the top, it's helping me here because it's kind of hard to tell the exact answer, but this is 36 plus 26 plus 3. So I would just add together those numbers. And after I add those numbers together, I'll get 65 people. Okay, circle graph is the next part, next kind of graph we're looking at. It's best used if you're looking at part to whole or percents, or comparing sections of something. The whole circle is 100% of the data. Each section or sector is just one part of it. So here is a circle graph on types of bicycles purchased and the different types. And the information here says, in 1 year, people in the U.S. purchased 16.6 million bicycles. The circle graph shows the types of bicycles purchased. Use the circle graph to answer each question. How many of the bicycles purchased were hybrid bikes? Now, it doesn't say what percent, because I could just look at the graph and say, oh, it's 9%. I need to figure out what's 9% of 16.6 million. So I'm going to set up a proportion. So for our proportion, we have 9% over 100 equals part over whole. Well, the whole is 16.6 million. So I would cross multiply and divide, and I would get 1.494 million. So what they did then is wrote it as a number in the millions. So 1.494 is 1,494,000, or you could write 1.49 million. Okay, they rounded it then to 1.5 million. So any of those answers are fine. All right. For the year shown, a reporter claims that consumers purchased a total of nearly 10 million mountain bikes and youth bikes. Is this claim valid? Okay, what we're going to do is check it. So we're going to set up a proportion. And they're talking about mountain bikes and youth bikes. So mountain plus youth together would be 37 plus 26. Which would be 63% over 100. And they're asking, are they correct? Is 10 million correct? Okay. And remember, it's out of 16.6 million, the total. So they're asking, is 10 million out of 16.6, is that 63%? So we could cross multiply 16.6 times 63 and divide by 100 and see if it's nearly 10 million. 16.6 times 63 divided by 100 is 10.458 million. So she's saying nearly a million. So her claim is not valid. It's just it's a little bit too less. She needs to go a little bit higher. It's like 10.5 million. Okay. All right, now we're going to look at a line graph and answer the question. If the cost of the dance increased at the same rate between 2003 and 2004, so 2003 isn't on here, we start at 2004 right here. And they're saying if I went backwards and went at the same rate as this, backwards, as it did between 2004 and 2005, what was the cost of the dance in 2003? So what I'm going to do is see how has it changed between 2004 and 2005. So this is at 3,000 and this is at 2,900. So that would be raising by 100. So if I went backwards to 2003, it would be 2,800. So it would be 2,800. So we found the difference between 2005 and 2004, and that was $100. So if I subtract 100 from 2,900, that would be $2,800. All right. Next lesson is (9.8). And we're going to look at misleading graphs and statistics. So they're often used in advertisements to make them visually appealing. Some are misleading to make people want to buy stuff. Okay, so here I have a line graph, and they're asking us to figure out why is it misleading. So I'm looking here, and it says 2002 is going up by 2s, good. But here, this is going up by 10s, and then 2, 2. So this is misleading because the scale on the y-axis is not equal intervals. Okay, this one, I've got soup cans, each can stands for 100, each box of cereal stands for 50, and each box here stands for 20 cases. So this is misleading because each of these pictures aren't worth the same amount. Okay, let's look at this one. Why is this misleading? Okay, so in year 1, this is the rate of return, and it keeps going up. The scale is good, but here this says projected. That means that this hasn't actually happened yet. So that is misleading because they're just predicting that will happen. It hasn't actually. Okay, this one, Mommy, I'm filming a video, hang on. Where's the remote for upstairs? Okay, so this one seems to be good. It has the names of the juices, and then it has this break in the graph, and then it's going up by 2s. So breaks and graphs are okay to use, but sometimes they can be misleading. So if we have a break in the graph, it can make it seem like grape is like double as popular as cherry, but really it's only 4 more. So a break in the graph is okay, but in this case it makes it seem that grape is way more popular when really it isn't. Okay, let's skip that. Okay, now I have identifying misleading statistics, and this one I don't think we're going to put this on the quiz because it's kind of hard to answer the questions. But why are these statistics misleading? 4 out of 5 dentists surveyed preferred ultra clean toothpaste, and shopping at Save-A-Lot can save you up to $100 a month. These are claims I see all the time in commercials. So the first one says, the statement does not give the sample size or state what it was compared with. And letter B it says up to 100, so that could be, $1 only that you're saving. All right, next one. Sam scored 43 goals for his soccer team during the season, and Jacob only scored 10. A reporter claims that Sam is a better player than Jacob. So that's misleading because maybe Jacob was playing defense and he doesn't really get the chance to score goals, so he might have done a lot of work as defense and still is a good player. All right, that is it. Hopefully that makes sense, and have a good day.